These are the notes on arc length and sector area. So the first thing we want to talk about here is that we want to make a distinction between the measure of an arc and the length of an arc. So if we had a circle like this, we had a circle center B, okay, and we have points A and C on the circle. Okay, we know the right angle is 90 degrees, and so this is our central angle. Since the central angle is 90, the measure of the intercepted arc is going to also be 90 degrees. Okay, if we look at our smaller circle down here, we again see a right angle, so this time DF is going to be 90 degrees. So even though we have a smaller circle, the measure of arc DF is equal to the measure of arc AC. They're both 90 degrees. There's 360 degrees in each of these circles. They're both 90 degrees of that 360 degrees. What we want to talk about with arc length is the actual distance along the circle between D and F. So it's not the measure of the arc, but the length of the arc. So if we had a radius of 10 in the first circle and a radius of 2 in the second circle, we're going to find that the length of the arcs are going to be different. Okay. The length, and the same thing then with the area. The area of this region is obviously much greater than the area of this region, even though the angle measures are still the same. So arc length and sector area are what these sections are. So again, we've talked about arc measure. Okay. We've talked about arc measure. Now we're going to talk about the actual length of the arcs. Okay. So let's look at examples 1, 2, 3, and 4 here on arc length, and then the next 4 are on the sector area. Okay, we want to find the length of EF, not the measure of EF. We know the measure. Here's EF. The measure of arc EF is going to equal 120. We don't want to find the measure of EF. We want to find the length of EF. So to do that, if we look back at our formula from that we had just had right there on the top of your note sheet. Okay. We got them both written on the note sheet here, right on top. Arc length is the measure of the arc. So we know the measure of the arc is 120. Well, let's write the equation down. X over 360 times 2 pi r. So basically, let's just break this up into 2 pieces. Let's look at 2 pi r. Okay, so if we want to find the circumference of this circle, circumference would be 2 pi r. We know the radius is 6, so the circumference would be 2 pi times 6, which is 12 pi. So all the way around the circle is 12 pi meters. Okay, which ends up being, 38-ish meters. So around the circle is about 38 meters. But we don't want the length of the whole circle. We want the length, or the length of the whole circle is the circumference. We don't want the whole circumference. We only want part of it. We want the part, E and F here, that's 120 degrees. Okay, so we need to multiply by a portion of the circle. So this is telling us the circumference of the circle. And then this is telling us what portion of the circle we are looking at. So in our case, 120 divided by 360, which is going to reduce down to 1/3. So we're only looking at 1/3 of the circle, meaning we're only looking at 1/3 of the circumference. So whatever the circumference is, we're going to have to multiply that by 1/3 because it's only 1/3 of the whole thing. So that's kind of what this equation is saying. This is telling us here's the circumference, 2 pi r. Here's what portion of the circumference we're looking at. And we're looking at only 1/3 of it because we're only looking at 120 degrees. And 120 degrees out of 360 degrees is only 1/3. Right, so let's put that all in here. So again, 2 pi r we said was 2 pi times the radius of 6. Okay, and then we have 120 degrees is our measure for EF, so that's 120 divided by 360. So I can erase more of this. Okay, so x over 360 times 2 pi r. Okay, so the measure, x being the measure we're looking at, okay, so instead of x, we're putting in 120. Okay, this is 120, so we're putting it in. Okay, so we're looking at 1/3, 120 divided by 360 is 1/3 of the circumference, which is 2 pi. So that's going to lead us to 12 pi over 3, which is 4 pi meters. That's our units. Okay, 4 pi meters. I don't want to confuse you with the units, though. Let me just say the circumference is 4 pi. The portion of the circumference that is our EF, right? So we have a circle. The circumference of that is 12 pi. It's 2 pi r. So 12 pi is the circumference. But EF is not the whole circumference. It's not the whole circle. It's only a part of it. And it turns out that it's only 1/3 of it. 120. It's only 120 degrees out of 360. So it's only 1/3 of the circle. So we multiply 1/3 by the circumference, and we get 4 pi. So this 1/3 of it is 4 pi meters. Same thing here. So we want to find the length of CD. Again, the angle measure of arc CD is 60 because the central angle is 60. Okay, but we're not looking for the arc measure. We are looking for the length of it. So that's going to depend on the radius. We know the diameter is 24. So we know the radius is going to be half the diameter. So we know the radius is going to be 12. We did the diameter divided by 2 is 12. Radius is half the diameter. The diameter is twice the radius. So they're telling us the diameter is 24. So we know the radius is 24 divided by 2, which is 12. From there, we have 60 degrees. The arc is 60 degrees out of a total of 360. So we're only looking at 60 out of 360. Right, we're only looking at which is going to be a sixth. Right, so we're looking at a sixth of the whole circle. Okay, and we multiply by 2 pi r. Let me write the equation out, actually, though. So here's our equation. Okay, so 60 divided by 360 equals 2 pi times 12. So that's going to be, well, it's not equals, it's times. Okay. And then you can just add that. You can put that on the calculator right away, or we can simplify it. So again, this is 1/6. 60 divided by 360. So this is just, this arc CD is only 1/6 of the whole circle. And the circumference is 24 pi. So again, 24 pi divided by 6 is going to give us a length of 4 pi. So you notice how these angle measures are different, but the length is still the same because the circles are different sizes. Remember, all circles are similar. So similar circles, similar arcs are going to have the same measure, but they're going to have different lengths. Arc length is the length of it. Arc measure is how much it is out of 360. Okay, number 3, a circle has an arc whose measure is 80 degrees. Okay, so we have an arc measure of 80 degrees and whose arc length is 276.46 pi. What is the diameter of the circle? So we know arc length. Okay, we didn't write these as an equation, and I didn't write it as an equation because what they give you here, the formula here, it doesn't have an equation. It just gives you the formula for it. So let's make it into an equation. Really, we could have said arc length equals E. So let's do that here. Arc length is going to equal, so x over 360 times 2 pi r. Okay, we know the arc length is 276.46 pi. Okay, we know the measure of the arc is 80, so it's 80 over 360 times 2 pi r. Okay, what is the diameter? So the diameter is twice the radius, so what we need to find is the radius, and then we can double it and find the diameter. Okay, so we have 276.46 pi equals 80 times 2 is 160. So we have 160 pi over 360 times r. I'm just going to put this all in the calculator. Okay. So 160 divided by 360 is 4/9. So let me get a 0.4. Okay. So, well, let's do it this way. So, yeah, let's just write it up. So 160, let me do it. 160 times pi equals divided by 360. Okay, is 1.4 r. Okay, and then on this side we get 276.46 times pi, which is 868.5. Okay, divide both sides by 1.4. Okay, we get a radius of 600 n. R equals 620.4. Multiply by 2 to get the diameter. So our diameter is 1240.8. Well, check that because I'm not sure that looks right. So the arc length is 276.46 pi. Okay, that's good. The diameter, so x over 360 times 2 pi. We know the arc measure is 80, so that's 160 pi, which is about 450. Yeah, so that looks good. Divide by 1.4, divide by 1.4, so we're good. Our diameter is 1240.8. Okay, number 4, find the measure of the central angle of an arc if its length is 43.98 pi and the radius is 18. So let me delete all this. Okay, and again here we're going to have arc length. Okay, the measure of a central angle, that's x, right? Because the central angle equals the arc length. If it's, okay, and then we have 360 times 2 pi r. Okay, arc length is 43.98 times pi. Okay, we want to find x, that's over 360. We know the radius is 18. Okay. So we can put that in 2 pi times 18 divided by 360 is 0.314. 0.314x is on that side, and then 43.98 times pi is 138.167. Divide both sides by 0.314. So divide by 0.314. And we get 440.0. 440.0 would be our, there's no unit here, but that would be our measure of our, that doesn't look right. The arc length is 43. Yep, that looks good. 2 pi times 18. Looks good. Divided by 360 looks good. Well, yeah, that doesn't make any sense. The problem doesn't make any sense. The arc length would not be. The arc length is bigger than the circle, right? So if we found the circumference here, 2 pi r, that's 2 times pi times 18, which is 36 pi. So we equal, yeah, so if you look, this is the circumference, right? Okay, the arc length is equals 44 pi, about 44 pi. Right, if we rounded it, it'd be 44 pi. So how is the circumference has to be greater than the arc length? And that's not true. So 440 degrees, I guess, but this problem doesn't make much sense. It's good because we haven't done this in class yet, and we can just skip it. We'll just do 1 through 3. Probably for the best that way. Okay, calculate the sector area below. Okay, sector area is the same principle, except this time instead of finding the length, we're going to find the area. All right, so we want to find the area of the shaded region. Okay, so we're going to use, so sector area is going to equal x over 360, x being the length of the arc. The measure, nope, not being the length of the arc, being the measure of the arc. So the measure of the arc is 120 because the central angle is 120. Then we want to multiply by the area of the whole circle, which is pi r squared. So again, let's look at this, break it down. Area equals pi r squared. Okay, that's this portion. So our area here is pi times 16 squared. That's 196 pi. So, 256 pi. 14 squared is 196. So this is 256 pi. So that's our area. So the area of all of this is 256. But we don't want the area of all of that. We just want the area of the shaded region. And again, we've said since the arc is 120 and the angle is 120, that's 1/3 of the 360. Okay, so we only want this portion of the circle, the 120 degrees part. So it's going to end up being 1/3 of the circle. So if you put that all together, okay, we're going to get 1/3 times the area of the whole thing. So sector area is going to equal, again, it's 120 over 360 times pi 16 squared. Okay, so again, you're going to get 1/3 times 256 pi. 256 divided by 3. So 256 pi divided by 3 is 268.1. So our sector area is going to be 268.1. Okay, 268.1. Right, so the whole area should have been 3 times that, right? We said it was 256 pi. Right, so it's, 3 times. Okay, circle has a radius of 12 inches. Find the area, area of sector whose central angle is 120. So again, just like the one before, the central angle is 120. We want to find the area. So again, it's going to be 120 over 360. Okay, but this time it's going to be times pi. Radius is 12, so pi 12 squared. So the area of the circle with radius 12, and this piece, this angle is 120. Okay, it's going to be, again, this is 120, the measure. All right, so 120 over 360, it's a third of the circle. You're multiplying by the area, which is 144. Okay, so 144 pi divided by 3 is 150.8. The area of this sector is 150.8. Right, it's 1/3 of the total area. The total area was 144 pi, but we don't want the total area. We want the area of just this piece. We know 120 is a third of 360, right? So 120 divided by 360 is a third. So we're multiplying only this part, which is a third of the circle, right? We only wanted the area of this part, which is the area of 1/3 of the circle. So 1/3 times the area of the whole circle will give us the area of just that sector. Inches, they have units on this one, so this one would be inches squared. Okay, the area of a circle is 225 pi inches squared. Find the area sector whose central angle has a measure of 45 degrees. So again, if we have an angle, a central angle of 45, we know the arc measure is also going to be 45. So that is 45 out of 360. And we're multiplying by the area. So it's telling us the area is 225 pi. Okay, 45 degrees out of 360 is 1/8 of the circle. So we don't want the whole area, we only want 1/8 of the area. So we multiply 1/8 by 220, the area of the whole thing, which is 225 pi. So 225 pi divided by 8. We only want 1/8 of it. That's going to be 88.4. So again, we can write this as an equation. Sector area equals sector area equals sector area equals. Okay, 1/8 times 225 pi. Last one, find the measure of the central angle if its sector area is 157.1 pi. So again, sector area is going to equal x over 360 times the area, which is pi r squared. So again, sector area we said is 15.7 pi. That's going to equal x over, we're trying to find x, right? We're trying to find the measure of the central angle, which is also the same as the measure of the arc. The measure of the central angle and the measure of the arc are the same. And then we want to multiply by pi, the area of the whole thing. So pi r squared, which is pi times 6 squared. Okay, I'm going to put this in my calculator. I get 15. Well, let's do this side first. 6 squared is 36 times pi. Then we want to divide by 360. So that's 0.314 pi. 0.314x. Okay. Then we have 15.7 times pi, which is 49.3. Okay, then we can divide by 0.314. Okay, we get 157.08. X equals 157.08 degrees. Degrees. So the measure of our central angle is 157.1. So again, the idea here is you're taking the circumference. Okay, you're taking the circumference, which is 2 pi r. Okay, so this is 2 pi r. Okay, but we're not using all of it. We're only using a part of it. So we're taking the measure of the arc and finding what percent of the arc we're talking about. If we're talking about 120 degrees, that's a third of the arc. So then we want only a third times 2 pi r, which is going to give us the length of this arc. So again, the angle measure and the arc length are not the same thing. Okay, and then again for secant area, it's the same thing. So the area of the whole circle is pi r squared. We're not looking for the area of the whole thing. We're only looking for a piece of it. And so we want to multiply by what piece of it we have. Again, if this is 120 degrees, then we only have 1/3 of the circle. Right? So, right, 1/3 of the circle. So 1/3 times the area of the whole thing is going to give us the area of this sector.